Alright, so we're going to start today by looking at triangles who have angles that are 45 degrees, another 45 degrees, and a 90 degrees. So remember that all triangles, the angles add up to 180 degrees, and if you do 45, add 90, that will make 180 degrees and will make a triangle. Now, it's going to be a right triangle because of the 90 degrees, but what's special about it is that these two are 45 degrees. And if these two angles are 45 degrees, it means the two sides across from them are going to be congruent. So this is going to save us some steps if we know these relationships. And you want to make sure that you write all this down in your journal nice and neatly, because you get to have open notes on your test. So you want to draw a triangle that's got a 90 degrees right there. This angle is 45 degrees, and this angle is 45 degrees. So here's what we know about this triangle. There's a right triangle. So across from the right triangle, this is the hypotenuse. I'll put a letter C there for hypotenuse. These two sides, remember they're called the legs, but since this leg is across from 45 degrees and this leg is across from 45 degrees, these two legs are congruent. So the legs here are congruent. That is what is special. These legs are congruent. That means that this is an isosceles right triangle. So we've got these two legs are congruent. So we're going to work through the Pythagorean theorem and see this special relationship, and then once you know the special relationship, you get to use it as a shortcut. So you know, in the Pythagorean theorem, one leg would be A and one leg would be B. And we'd write A squared plus B squared is equal to C squared. But since this is a 45, 45, 90 triangle, because these two angles are 45 degrees, that means that A and B are the same. So instead of putting B squared here, I'm going to put another A squared. Right? Because A and B are equal to each other. A is equal to B. That's what congruent means. So then if I have an A squared and I add it with another A squared, that means I have two A squareds. But then if I want to know what my hypotenuse is, I'm going to take the square root of both sides. So when I take the square root of this square that's on the C, the square root and the C undo each other. And when I take the square root on the A squared, that undoes each other, and that has A. But the 2 stays under the square root. So that's the Pythagorean theorem, and I've worked it out. And so look at this relationship. C is the hypotenuse. So no matter what these numbers are, the hypotenuse is always going to equal the leg times the square root of 2. The hypotenuse equals the leg times square root of 2. So if I'm on a triangle and I know what A is and I'm trying to go from A to C, if I'm going this way, I'm going to take my A and I'm going to times it by the square root of 2. But what if I was going backwards? What if I knew the hypotenuse and I wanted to figure out the leg? How do you go backwards from multiplying? How do you undo multiplying? By dividing. So if I know the hypotenuse and I want to go over to a leg, then I would divide by the square root of 2. Now, that might look a little bit weird, but we have to remember what this square root of 2 is all about. It's just a number, right? So turn on your calculator and just press square root of 2. Square root of 2 is a number 1.414213562, and actually it keeps going. This is not even the end of it. It's an irrational number, but we want to kind of keep in our mind that the square root of 2 is close to 1.4. So every time we write square root of 2, we want to think, oh, that's about 1.4. Alright, we want to look at something else. What happens if you multiply the square root of 2 times another square root of 2? I mean, you can do it on your calculator. Square root of 2, then times square root of 2. Press all those buttons. What's going to equal 2? Because the square root of 2 times the square root of 2, isn't that the same thing as saying you have the square root of 2 and you're squaring it? But squaring and square rooting undo each other. So the square root of 2 multiplied by another square root of 2 is just going to be 2. Now we said the square root of 2 is close to 1.4, right? Close to, but not exactly. Well, what if you do 1.4 times 1.4? That's 1.96. Is that close to 2? Yes, but not exactly, because this isn't exactly the right amount, but it's close to it. Okay, so let's look at what happens when we actually have some numbers on our triangles and not just A, B, C. So this time, let's draw a triangle with our right angle down here. Alright, so we want to look and we say, oh look, we have a 45, 45, 90 triangle. So that means the two legs are congruent, right? This leg across from 45 and this leg across from 45. These two are the same. So x equals 7. Now, this y is the hypotenuse, right? You just put HYP for hypotenuse. So y equals, what this sentence right here tells me. The hypotenuse equals the leg times the square root of 2. So y equals 7 times the square root of 2. That's it. That's the answer. Now, if the problem said to find y and change it to a decimal, then you would do 7 times the square root of 2, and you'd put in your decimal, you'd round it to whatever place they said to round to. But for what we're doing right now, we can leave it as 7 times the square root of 2. We're not even going to change it into decimal form. Alright, so let's do one that looks a little bit different. Here's our right angle. 45 degrees, 45 degrees. This is x, this is y, and this is 10. Alright, so look at where your two 45 degrees are. Across from the 45 and across from the 45. You see those two are equal? So x is equal to y. X and y are the same number. But across from the 90, this guy down here, this is the hypotenuse. Alright, so look right here. If you know the hypotenuse and you're trying to go find a leg, then you divide by the square root of 2. So x is going to equal 10 divided by the square root of 2. And y is going to equal the same thing, 10 divided by the square root of 2. Now, we don't have to change that into a decimal. But if you're just like, yeah, but Miss Carter, just like, I wonder how much that number is. Well, if you press 10 divided by the square root of 2, and your answer is about 7.1. So doesn't it make sense that the legs are going to be shorter than the hypotenuse? Yes. So 7.1 sounds like a good answer. Alright, let's look at another one. Alright, so again, this relationship only works when you have a 45, 45, 90 triangle. So here's your two 45 degree angles. So these two sides are congruent. So x and y are going to be equal to each other. These are the legs. And then across from the right angle, this guy is the hypotenuse. So I'm on the hypotenuse and I want to go over to a leg. So I'm going to divide by the square root of 2. So I'm going to take 8 times the square root of 2, and I'm going to divide it by the square root of 2. Now, you can press all those buttons on your calculator if you want to, but how much is any number divided by its own self? 1, right? 5 divided by 5 is 1. 6 divided by 6 is 1. So square root of 2 divided by square root of 2 is 1. And 8 times 1 is 8. So x equals 8 and y equals 8. Both of the legs are equal to 8. Alright, let's do one more. Last one for our notebook. Here's 90, 45, 45. Here's x. Here's y. And this one is 5 times the square root of 2. Alright, so again, it's all about reading your triangle. Here's my 45, here's my 45. Across from the two 45s are the ones that are congruent. You see that here and here? These two are the legs. Right? These are the legs. This one over here across from the 90 degrees, this one is my hypotenuse. So my two legs are congruent. So if this leg is 5 times the square root of 2, x is 5 times the square root of 2. The legs are congruent. Now, I want to know this hypotenuse. My rule, if I go back to my other paper, the hypotenuse equals the leg times the square root of 2. If I know the leg and I'm trying to go towards the hypotenuse, I'm going to multiply by the square root of 2. So I'm going to take this number, 5 times the square root of 2, and I'm going to times it by a square root of 2. And again, you can type all this in your calculator, but the shortcut is square root of 2 times square root of 2 is just 2. So 5 times 2 is going to be 10. Well, let's look on the calculator, just to show you it is right. 5 times the square root of 2, right, and then you have to use your arrow button to make that square root n. Then you're going to times it by another square root of 2, and you get 10. I wonder how much just 5 times the square root of 2 is. Oh, 7.7. Does that make sense? Are the legs shorter than the hypotenuse? If they're 7.07 and that's 10, your problem should always make sense. The hypotenuse should always be the longest side.